imagine you have a cylindrical container with a radius r and a height h. Let's say a liquid is flowing into it at a rate of L litres per second. What is the rate of change of depth? So let's call the depth y. So the volume of liquid is equal to pi r squared, which is the area, times y, which is the depth of the liquid. Now we want to find the rate of change of depth, which is dy by dt. So we're going to differentiate both sides of the equation with respect to time. So dv by dt is equal to pi r squared dy by dt. dv by dt is the rate of change of volume, which is the rate at which this liquid is flowing in there. So we know that because it's given as L, which means that the rate of change of height, which is here, so dy by dt, the rate of change of height, is equal to 1 over pi r squared times dv by dt. So to put some numbers to this, section 18.5 in the textbook describes this situation where the container has a diameter of 5 meters, so r is equal to 2.5 meters. Liquid is flowing in at a rate of 1,000 liters per second, and we want to know the rate of change of depth. So putting these into the equation, let's just move that up a bit. We've got dy by dt, dy by dt is equal to 1 over pi times, the radius is 2.5 meters, so that's 2.5 meters, times rate of change of volume. Now we're given that the rate of change of volume is 1,000 liters per second. 1,000 liters is equal to 1 cubic meter. So this is going to be 1 over pi times 2.5 squared times 1. So if we put the numbers into that, we get the rate of change of height is 0.051 meters per second, or if I multiply that by 1,000, we get 51 millimeters per second. Let's just pause for a second and do a dimensional analysis on this equation. We've got dy by dt, which is the rate of change of height. Height is measured in meters and time is measured in seconds. So we've got length times time to the minus 1. And that is equal to, this is 1 over pi, pi is a dimensionless ratio, and this is meters squared. So this is going to be length to the minus 2 times, this is the rate of change of volume, which is going to be cubic meters per second. So that's going to be length cubed times t to the minus 1. So we've got L to the minus 2, L cubed, so that will cancel with that. So we're going to end up with length times time to the minus 1, which is exactly the same on both sides of the equation. So the equation holds. So our answer of 51 millimeters per second is probably right. Given liquid is entering the container at 1 cubic meter per second and is leaving the container at a rate of 0.1 y meters per second, how long will it take the container to fill from 2 meters to 3 meters? So let's just remind ourselves of our equation, which is dv by dt is equal to pi r squared dy by dt. Now I've left a bit of space here because water is now leaving the container as well, so that's going to be minus, I'll call it ay for now, but we know that a is equal to 0.1. We're going to get dt is equal to pi r squared that's all constant, times the integral of dy over dv by dt minus ay. We're going to integrate both sides. So let's move that up a bit. So t will be the result of this integral, and on the right hand side we're going to get pi r squared, and the integral here is going to give us the natural log of dv by dt minus ay divided by minus a, and we're going to integrate that from a depth of 2 meters to a depth of 3 meters. Right, so let's put these, let's set out the calculation. So that's going to equal pi times 2.5 squared, and that's going to be over minus 0.1. Then we're going to get the natural log of 1 minus, this is 0.1 times 3, so that's going to be 0.3, minus the natural log of 1 minus, y is going to be 2, so that's 0.1, so that's going to be 0.2. So putting numbers into this, we're going to get minus 196.35 outside of a bracket containing minus 0.3567 minus 0.2231, which, when we multiply that out, is equal to 26.21 seconds. As a sanity check, let's imagine there was no water flowing out. So we've got water coming in at 1 cubic meter per second, and we've got pi r squared, which is equal to 19.63. And if we take 1 meter depth, because we've gone from 2 to 3 meters, that's going to be cubic meters. So if water wasn't flowing out, it would take 19.6 seconds, and if water is flowing out, it takes 26.21 seconds, and that seems quite reasonable. So our sanity check says that we can be confident in our answer.